A concept on a computer eventually became a real rocket. However, getting from the first design to the launch pad was never ever going to be straightforward. The design changed, problems came up, and different ideas had to be tested before we settled on a final configuration. Now, after a week of preparing, we took our rocket to the Lignum National Rocketry Competition. I was tasked with the physical aspect of the rocket, whereas Jeremiah Frith, alongside Joshua Gordon, was tasked with the electronic components of the rocket. The project started with the design. The initial concept was a twin-stage rocket, and in rocketry, a stage is a section of a rocket in which performs a specific part of the flight. Once that stage has completed its job, it will separate from the rest of the rocket, reducing the mass that the remaining rocket will have to accelerate. The first stage would provide the initial boost, and after completing its job, it would separate, allowing the second stage to continue the flight. Though it was an ambitious concept, the simulations showed that it had potential. However, the simulation was only the beginning. The real challenge was turning that concept into something that could actually be built, operated, and flown reliably. From there, the design moved from the computer to the workbench. The focus shifted from what looked good in a simulation to what would actually work in reality. Stability, weight distribution, aerodynamics, I could keep going. Every component had a purpose. The fins had to keep the rocket stable, the body had to be strong enough for flight, the recovery system had to function, reliably, and the payload had to survive the flight. Nah. Building the rocket also revealed challenges that weren't obvious in the original design, because measurements had to be precise, components had to fit together properly, and changes to one part of the rocket could easily affect the performance of an entire rocket system. So the build became a process of assembling, checking, adjusting, improving, and rebuilding. So as development continued, the original design began to evolve. The two-stage concept was one of the first major ideas to be reconsidered. The goal wasn't to make the most complicated rocket possible. The goal was to build a rocket that was practical, stable, and capable of completing the competition requirements. That meant going back into the design, running more simulations, adjusting the configuration, rebuilding components, and retesting the results. Eventually, the design started to look like the rocket sitting in front of us. The body was assembled, the fins were secured, the recovery system was prepared, and the payload was ready. The final checks were completed, and after weeks of development, the rocket was finally ready. Competition day started with the journey to the launch site. After spending so much time designing and building the rocket, it was finally leaving the workshop, aka the Wolmer's library, and heading towards the first real test. This was the point in which everything started to feel real. Upon our arrival, there were teams from different schools, each with their own designs, approaches, and even executions to the challenge. Seeing all of the rockets lined up made it clear that this wasn't just about building something that could fly. It was about preparation, execution, and how well each team could put its design to the test. The final checks were completed, the rocket was prepared, and everything was ready for flight. At this point, there was nothing left to change. The design was finished, the rocket was ready. There was nothing to lose. Looking at the rocket on the launch rail, it was hard not to think about how far the design had come. What started as a two-stage concept on a computer had gone through multiple iterations and eventually became the rocket sitting right there.
Guys, 8, 7, 6, 5, 4, 3, 2, 2, 1. Whoa! Jeez! Woo! Oh my God! Wow!
After the flight, all that was left to see was how the work had paid off. When the results were announced, we were placed second. second place at the Lignum National Rocketry Competition. After everything that went into the project, seeing that result was an incredible way to finish the competition. More than anything, this project would have shown us what engineering actually looks like. The first design isn't always the final design. Problems are gonna arise, and sometimes the best solution is to go back, rethink the approach, and try again. The rocket changed significantly from its original concept, and every change came from something learned during the process. That's what made the final result meaningful, not the second place. Joke me, I'm still felt amazing. Guys, it felt amazing.